Hello class, this is Miss Radford for another episode of Up the Mountain, and this time ISTEP practice. So ISTEP is coming up very soon, so I know that you're excited to get all the tools and resources you need to be successful. So there was a problem I posted last week, and a few people responded to it. I put the problem on Facebook, and you just saw it at the beginning of this video. It is an ISTEP review problem on finding area. And it's an irregular figure, as you saw. So how do we approach a problem where we need to find the total area of a figure that is not a regular polygon, if you will? So we have to find the total area in square feet of the room. So the first thing you want to do is look for well-known shapes like triangles and rectangles. And in this figure, we see both of those figures, triangles and rectangles. So once we know what type of shapes we have, we'll find the area of each of those and then add all the areas together to find the total area. So again, in this figure, we see two congruent triangles and then two rectangles of different sizes. So what are we going to do first? We'll find the area of the triangles. Since they are congruent, it shouldn't be too difficult. And of course, we need to know the formula for area of a triangle, which is 1/2 the base times height. Of course, this is simple, but we need to make sure we have both of those items. So we have the height, which is 4 feet, but the base is not readily given to us. We have to find it. So refer back to the picture, if you will. So if you notice, the base of the triangles is actually a part of other sides of this figure. So what we'll have to do is subtract off known pieces of those sides, and then we'll be left with the remaining length of both triangles. So 21 minus 8 minus 7 will give you 6 feet. But again, since we have two congruent triangles, we need to split that in half in order to find the length of one base of a triangle. So we see the base is 3 feet, and now we just plug and chug. So the area of one of the triangles is 1/2 times 3 times 4, which is 6 square feet. And of course, since we have two triangles, we'll do 6 times 2 to get 12 square feet. Now we need to go to the rectangles. If I can get there ever. So here we go. We are reviewing again for ISTEP, and we are finding the total area of an irregular figure, which they call a room of Amy's, right? So she's trying to figure out how much carpet to put down. So now we find the area of the rectangles. So we have a formula for area of a rectangle, and that's length times width. Since we have two different size rectangles, we'll find the area for each separately. So the first, of course, is 8 times 4, and that's 32 square feet. And then the area of the larger is 21 times 4, which is 84 square feet. So we remind ourselves what we need to do in order to get the area for the entire room. And that is, of course, to add all of the areas that we just found together, 12 plus 32 plus 84, and that will yield 128 square feet. So that's how much carpet she needs in order to cover her floors for this room. If you have any questions, of course, and you want some extra credit, go ahead and give me some comments at the end of this video. On YouTube, you know what to do. Initials and class period. And then if you can't do that or don't want extra credit, go ahead and talk to me tomorrow in class. All right, have a great day. Wish I could be there. Bye-bye.